This is Sung, and I'm your online maths mentor, and I'm very excited to kind of talk to you today because we are going to start the Extension 1 course. So I'm really excited about that, and in the Extension 1 course, I'm going to start off by looking at coordinate geometry, okay? It's a good place to start. I'm going to look at coordinate geometry, and in particular, I'm going to start off by looking at angles between two lines. Now there's a number of things, there's a couple of things that we're going to look at with the in the extension course in relation to coordinate geometry, but the first one I want to look at is the angle between two lines, okay? So the first thing I want to do is go back to mathematics and go back to the 2-unit course and look at stuff that we already know, okay? Now the first thing that we already know is if you've got a straight line, let's call that straight line L1. So if we've got a straight line, and just say that the equation of the straight line is y is equal to m1 x plus b1, okay? Y equals mx plus b, m1 and b1, okay? Is the equation of your line. And that line makes an angle with the positive x arm of theta 1. Okay, so this is theta 1 here, this is m1 there, and this is b1 there. So you got this straight line, yes, there, right? The relationship between your gradient, which is m1, and your angle from the positive x arm, which is theta 1, is going to be m1 equals to tan of theta 1. All right, so that's what I got here. So m1 equals to tan theta 1. And the reason why that is the case, let me just go back and just do a quick recap on stuff that that you should already have covered or will cover in the 2-unit course if you're doing this simultaneously with the 2-unit course, is this, right? Theta 1, all right, the tan of theta 1, if you were to drop a perpendicular there and make a right angle triangle, right, this bit here would be the rise of the gradient, but would also be the opposite side to the right angle triangle of theta 1. Yes? So your rise is equal to the opposite side, your run is equal to the adjacent side. Adjacent side. Does that make sense? Okay, so your rise over run is equal to m1. Okay, so your gradient is equal to rise over run, but your tan theta is also equal to the opposite over adjacent. Does that make sense? So that is why m1 equals to that's why m1 equals to the tan of theta 1. Does that make sense? Got it? All right, cool. So once we've got that, the other thing that I want to look at is what would be the angle between two lines. If we had this line here and we also had another line going this way here, what would be the angle between them? We can actually work that out. So let me just rub this out for a moment. Let me put the second line in. Do you see that? And because it's the second line, let's call it, a good name to call it would be L2. We're going to call that L2, and it's given by y equals to m2 x plus b2. Does that make sense? All right, so let's call that. And the angle, this angle here would be theta 2. All right. So m2, by the same token that m1 is equal to the tan of theta 1, m2 would be equal to tan of theta 2. Does that make sense? Cool. Now, the angle between two lines, all right, the angle between this angle and this angle would be this angle here, and we're going to call that theta, just theta on its own. Now that theta would be given by theta 2 minus theta 1. Can you see how that's the case? Right? Can you see the axiom or the reasoning that I use to work out that theta is equal to theta 2 minus theta 1? That this angle is equal to the difference between these two? Yep. If you look carefully, you will notice that basically this is the case because we are using the external angle of a triangle theorem. So in this triangle here, the two internal opposite sides, or internal remote, the two internal remote angles added together will give you the external angle. of the other side, of the other angle. Yep, does that make sense? So this angle plus this angle gives you this angle, so therefore this angle must equal to theta 2 minus theta 1. Does that make sense? All right, so theta 2 minus theta 1 gives you that angle, right? So in other words, the tan of that angle is also equal to the tan of theta 2 minus theta 1. Does that make sense? All right. Here's the other thing that I want you to know though, all right? Sometimes theta 2 minus theta 1 is not going to be positive. It might be a negative number, all right? The difference between them, all right? So what we need to do is put absolute value signs around theta 2 minus theta 1, because your angle, we don't want the angle to be negative. The angle between the two lines, we want it to be the positive angle, all right? So in other words, we put the absolute value signs there to account for the fact that if you minus one angle from another angle, it might be negative, right? So you put that there to make it, to adjust it into the positive again, all right? So you've got tan theta, so you got tan theta equaling the tan of one angle minus the other angle, okay? All right. Now you haven't learnt this yet, and you probably won't learn this till much later, but I want you to know that later on in the course when we do trigonometry or do further trigonometry in the extension 1 area, you know, in the extension 1 curriculum, you will learn a formula called the compound angle formula for tan. Right? And if we apply the compound angle formula for tan, you will have to know this eventually, but you don't have to know it now. If you apply the compound angle formula for tan, what you get is that tan of one angle minus another angle, the tan of one angle minus another angle is going to be given by this formula. All right? So in other words, tan 2 theta minus tan theta 1, all right? All over 1 plus tan theta 2 times tan theta 1, okay? And because this was in absolute values, this also needs to be in absolute values, right? And because this is the compound angle formula for tan, what we can do is substitute out the tan thetas for the gradients, okay? Because after all, tan theta 1 and tan theta 2 are equal to M1 and M2. Yes? And so that is your formula to work out the angle between two lines given the two gradients. And that's what we've got over here. So let me come around this side. If you want to find the angle between two lines and all you have are the two gradients of the two lines that you've got, then you can find that easily by using the formula M1 minus M2 all over 1 plus M1 times M2, all in absolute value, okay, all in absolute value signs, all right? And that'll give you the acute angle of the angle between two lines. Does that make sense? Cool. Now, I will just say this, because sometimes the question might ask you, instead of finding the acute angle between two lines, they might ask you for the obtuse angle between two lines. Where they ask you for the obtuse angle between two lines, what you need to do is find the acute angle and obviously minus from 180. So in other words, the obtuse angle might be this angle here. You take that angle, you work that angle out first, and then minus from 180. Does that make sense? And that'll give you the angle between two lines, or give you the obtuse version of that. Okay, good. Now I know that I went through things a little bit quickly, and I will be going through things at a much more accelerated pace with the extension 1, with the extension 1 course, assuming that you guys can keep up. But please, if you are getting stuck, you have the benefit of going back, rewinding and watching the videos again. So please do so until you understand. And in the next episode, I'll actually do maybe an example or two of how we apply this formula to questions that might be more of an HSC nature. Okay, the typical questions that you might see in the HSC course. Okay, So thank you very much for watching. I'll stand to the side so you can see things, but this is Saul signing off. I'm your online maths mentor. Thank you very much for watching. Bye.